Weather and climate. So let's start off by defining differences between climate and weather. Climate is the average weather um, that occurs in a given region over a long period of time, while weather is the short-term conditions of the atmosphere in a local area, which includes like temperature, humidity, clouds, precipitation, and even wind speeds. For an example, in the shrubland biome, the climate or average weather in the summer is hot and dry with temperatures reaching approximately up to 100 degrees Fahrenheit, while in the winter, the temperatures stay around a cool and moist 30 degrees Fahrenheit. The shrubland weather now, which is like the short term, for an example of a shrubland biome would be in San Diego, and it is experiencing currently 70 degrees, 6-mile-per-hour winds, and 52% humidity. So why does weather and climate differ? Many different elements contribute to the differing weather and climate patterns within an area. They all change the solar and energy levels, however. First, at high altitudes, sunlight must pass through more atmosphere and thus loses more of its energy than it would in the tropics. Because the energy is lost as it passes through the atmosphere, the solar energy reaches the equator way more than in the mid-latitude and polar regions. So you can see like over here, the sun, it has like a direct access point to the areas that are right around the equator rather than the poles that don't have as much access. Secondly, the amount of surface area over the sun rays distributed causes difference in climate amongst areas. When the sun rays hit the equator, solar energy is distributed over a smaller surface area than the poles. Solar radiation hits the equator directly, and all energy is absorbed over a small area. At high latitudes, the same amount of energy is spread out over a large surface area. And finally, albedo changes the climate and weather of an area, because albedo is the percent of incoming sunlight reflected from a surface. Earth has around 30% in average, but its tropics have 10 to 20% because of the dark green foliage that absorbs a lot more sunlight and heat energy. While the polar areas have about 80 to 95% albedo because of the white snowfall. It's so white that it reflects the sunlight rather than absorbs it. So there's less heat. Moving on to evaporation and condensation, I wanted to go over these before we get into air currents and convection currents, because these are two major elements in air circulation. So evaporation in simple terms is the change from liquid to gas. When liquid is heated, water becomes vaporized because the molecules in the liquid absorb heat, which makes them move around quicker, giving them the energy to break the bonds that connect them to water molecules. A real-life example would be a hot summer day after a rainstorm from the previous night in our lovely town of Basking Ridge. There are puddles on the sidewalk from the rain, and as the day progresses and the heat increases, the puddles seem to disappear, and that is because of evaporation. Next, the inverse of evaporation is condensation. This means that it is the change from a gas to a liquid. The molecules in the air cool down and lose heat energy, which causes them to slow down their movement, which makes the molecules move closer and closer together until they return to a liquid state. Another example would be a summer morning in Basking Ridge at like around 6 a.m. You look around, you can see dew all over your car. And this is because the air molecules cooled down so much that they changed into a liquid state, thus condensation.